Hey guys, welcome back to Understanding the Nuclear Energy course. We are now in week 4. That means we are halfway through the course. Congratulations to everyone. In week 3, we introduce you to the Fukushima accident. Now, in this discussion video, we'll share more about 3 Mile Island and Chernobyl accident. Now, with me I have Joris, and we are going to discuss 3 Mile Island and the Chernobyl accident. So I would like to start. The 3 Mile Island occurred in Pennsylvania in 1979. So what exactly happened?
Well, it was a combination of human error and technical failure. The failure of the feed water pump followed by a turbine trip resulted in a small break loss of coolant accident, and this led to an increased core temperature, oxidation and partial melting of the core.
Oh, partial melting of the core. And what are the consequences of these?
Well, the overheated fuel rods and the molten material oxidized and produced hydrogen gas that accumulated in the containment building, along with the volatile fission products. And well, there was a door to the auxiliary building that was open, so these gases could escape and into the auxiliary building as well.
And then the hydrogen gas exploded. How large was the damage actually?
Well, yeah, part of the hydrogen gas exploded in the containment building, but the building itself wasn't damaged. Okay, thank you for that overview. And now we'll talk something about the Chernobyl accident. What happened there? Well, first of all, multiple regulations were violated, and additionally, the RBMK reactor, of which the Chernobyl Unit 4 reactor was one, had several design shortcomings. A test intended to improve the safety of the reactor by using the rotational energy of a tripped turbine led to a catastrophic accident. Note that the RBMK reactor does not have a containment building above the core. And due to operation errors, the plant was operated at a 1% power level, which was far below the permitted power level, that is 20%. Before the test started, the plant was operated at 7% power, with only 8 control rods in the core and 1 turbine active. Once the turbine was disconnected, a power increase started after 20 seconds. And to stop it, the operators manually activated the insertion of the emergency rods. But by doing this, the graphite follower entered the core first, which resulted in an uncontrolled nuclear chain reaction and the destruction of the power plant.
Is it because graphite is a strong moderator?
Yes, exactly. The power excursion caused fuel fragmentation and massive damage to the reactor building and its containment. A big radioactive plume arose over Chernobyl, and the wind transported it to the neighboring countries, so Belarus and well, Ukraine itself. The graphite moderator burned for 7 days, which led to the melting of the rest of the core material and the release of even larger amounts of fission products.
Okay, thank you, Joris. That was very insightful. We hope you found the discussion of these accidents helpful and knowledgeable. The PowerPoint presentation without the commentary is available in the additional subsection. This week, we will take a look into the nuclear fuel cycle, right from mining the uranium ore all the way to the final disposal of the nuclear waste. To help you understand these stages better in the fuel cycle, we will first learn about the chemical properties of uranium. Enjoy this week's lecture series.